Alright, welcome everyone, welcome back to devlog number 3. So, we have a couple of things that we have to fix, I think. So currently what the problem was that this guy just moved up when there was collision of our arm. So I think we just have to fix that because this is our base, right? And also potentially fix the rotation. Cool. Second of all, I think we can delete that actually here. That was just a test, yeah. And second of all, I think we can take a look at the physics and see if we get a little bit more accurate collision calculations. So let's check this out. Default max dependencies, velocity, default contact offset. Great. Enable adaptive force. Simulation. Callback. Pairs mode, default contact pairs. Sweep. Default sweep and prune broad face offers performance adjustment. Overlapping, blah blah, words supervision, friction type, enhance determinism, improve patch friction, solver type. Okay, what is the difference here? Choose solver, default max angular speed, layer collision matrix. There's not really anything we can do. I feel like I thought I remember that we could increase the physics updates or something like that. Let's see. Physics update Unity, something like that. You can adjust the fixed time step settings in the time window. So allow time steps in the time window. Mesh color must have much higher performance. Shape of the mesh. Colliders will be controlled actively as a single compound collider by the rigid body on the parent. Wheel colliders and so on. Okay, so time maybe is something that we can look at. So fixed time steps, a frame rate independent interval that dictates when physics calculation and fixed updates events are performed. So does it mean a frame rate independent interval that keeps the worst case scenario? Okay, so worst case scenario is high, maximum particle time steps, and good is low. So can we just do something like, I don't know, something like this? Let's see. Yeah, let's try. So the problem was that it started to sort of shake. So this guy is touching our box. That looks good, right? I'm continuing to add forces here. But now when I sort of start to rotate it, it starts to sort of shake. I'm continuously pushing it downward. There's actually quite some friction. That's interesting. And now it doesn't move anymore at all. Wow. What happened? It doesn't want me to move it anymore. Is it because of the rotation or what? What? Okay. Interesting. Do we have anything else going on? What the problem might be here? So here this guy has some sort of a velocity, so I think it has some sort of a friction. It might receive it from like from the rotator or something like that. Wow, look at this. Interesting. So let's see, what can we do about this? Collision detection. What is the interpolation, by the way? Angular drag, and then here we have our rigid body. What about the box collider? Is there any sort of friction? There's no physics material. So maybe I sort of forgot to reset the velocity. Let me actually look at that. Oops, that is actually wrong. This is my script. So update, I'm changing the vector angular velocity to 0, but general I probably should also just dot velocity, velocity that what's going on? Why is this not picking up the velocity? So this dot rv dot velocity, there we have it. Okay, took a second. All right, so we also need that, I think, for the robo arm, which we're doing here. Okay, I'm not sure how much this is actually helping us, but okay. Yeah, okay, so let's see. Maybe this is already very good. Okay, let's check this out. You can rotate left and right. I feel like it's a bit laggy these days. Okay, rotating is working. So now as soon as I okay, look at this. I cannot turn now anymore. Crazy. And that must have to do inertia tensor world center. Crazy, why is this not just doesn't rotate anymore. That's very interesting. Where's the hinge joint currently? Okay. I'm not 100% sure. Maybe, I'm not sure if the setting I've done here screwed stuff up, but let's double check that. Rotating. But, you know, I mean, it just is impossible that this is shaking as much as it is. But so look at this. I mean, It's essentially impossible. This guy is almost detaching. So the question is if that hinge is correct bounce min velocity. Is there something I have to change still? I mean, yeah, this seems a little odd, I think. Twitter. Use limits force. Target velocity. Motor. Let me actually read this for a moment. Hinge joint. What can we do with the motor? If use motor is enabled. Interesting. Hints. To assign a connected body to your joint for it to work. Spring motor are intended to be mutually exclusive. Leads to unpredictable results. Okay. Use motor. What happens if I use the motor? I don't think this does anything currently. What is this supposed to be? To connect it. Let's check that again. Connected. What is that? Connected articulation body. Articulation body. Doesn't show up. What is this? Articulation bodies and where you build physics articulations such as robotic arm or kinematic chains with game objects that are hierarchically organized. Okay, that sounds great. An articulation body allows you to define in one single component the properties that you would similarly define through a rigid body and a regular joint in classic configuration. Of the articulation, you can only set up physical body properties. For any child game object within the articulation, you can set up physical body properties as well as the type and property of the joint that links the game object to its parent. Okay. Should I maybe physical body properties, joint anchor? Cool. Let me try that. Articulation body. So is that a different type of joint or what? I mean, I don't want to... Oops. Maybe I have to stop that. Let me just keep that here. So what do I do? Do I just articulation body? Can't add component articulation body to a rotator because it's conflicts with the existing rigid body. Okay, then let's remove that. Okay, hinge joint, remove, remove, apply. I hope it didn't happen. Okay, here, this is our backup. So let's add a articulation body. What can we do here? This is the root body of the articulation. Use gravity. I don't need that. Immovable. by force and torques only applied to the root body of the articulation. This probably means this is some sort of a base or something, but I'm not sure. Continuous, linear damping, angular damping. So what do I do? Alright, articulation body. For any child game object within the articulation, you can set up physical body properties. Okay, so that means this guy is supposed to be a child of this. So let's see. Oh god, I'm destroying everything. So let's bring that out just to have that. Rigid body, removing it. Articulation body. Okay, wow. So there's a lot of different more options we have now. Okay, so what can we do here? We're not even going to use the gravity, mass, I don't know, collision detection. Can be continuous, snap anchor to closest contact. Aha, because yes, the anchor kind of side of things. So what do anchor rotation, 90 degree, match anchors, anchor position. Ah, okay. Okay, this is our anchor. Okay, articulation joint, revolute, maybe, prismatic. Cool, this is fancy. Prismatic, fixed, revolute, and spherical. Cool. Okay, so let's use revolute, and then wait. Motion limited. Oh wow, very cool. All right. Should we let's just try what's going on currently. I hope this is not terribly bad now. Missing component exception. There is no rigid body attached to the arm. Okay, that makes a lot of sense. So then what do I do in the script? Am I just going in here and saying something like articulation body? And then what? Can I do the same stuff to the rigid body? Okay, let's try. Rigid body. Okay, I don't have a good feeling about this, but okay. 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 Hold on. So let's try to rotate. Okay, we're rotating, but it looks like this is very much fixed. Immovable. What happens? Nope. I don't want this to be immovable, so I can move it. But so something I have to change here, I think. Edit joints, continuous, match anchors, force limit, snap to, motion, match anchors. I don't know what that means. Okay. What is going on? I don't know what the hell this is, but match anchors, spherical. So what is going on here? This doesn't look too great. So my go-to would be to check if there is an example. joint anchors. Degrees of freedom and limits. Free spherical joint. Okay, so yeah, so what I would do is basically articulation, body, unity, example, if there is an example out there somewhere, because this is slightly confusing. Okay, let's check out Anya's website. Constraints. Oh wow, okay. Great website. Use articulation body to easily prototype industrial realistic motion. Wow. Okay. Unity simulation. I think this might make sense to check this out for a moment. Wow, this is a super cool resource page. Wow, I have to copy this. All right, I'll check this out. Give me a sec. Okay, so scrolling down here, we can actually, on the very bottom, we can find this robotics demo project, which is essentially this GitHub here. So let me actually really quickly clone that. So we're CDing into this, and then we'll be cloning this. Git clone. Wow, that's exciting. Very nice. So definitely it's always a good idea, I think, to kind of look at other people's stuff, how people do it. I think this is good. Or I think this is the project actually, ARM Robot. Let's choose another version. Yeah, let's choose whatever we have here, change version. If this is screwing things up, we're just gonna reinstall it. Okay, it's not matching, continue. All right. All right, so here we are. Let's check the project out. Gripper scene articulation robot. Wow, let's check out the articulation robot. I hope I should not have to check this out before. Wow, this is such a cool little robot. Wow. Well, I hope eventually ours is going to look similar. Okay, so let's check this guy out. So we have, oh wow, very cool. All right, so we have a mesh collider. We have a base. Okay, so wait. So here we have our articulation body. Cool. Use gravity, immovable. Okay, well, we can do something like that. So, but that would mean, I think, maybe we're just gonna do that on the robot agent. So let's say this is our robot agent, this is our base, this is our rotator, this is going to be having an articulation body. Wow, this is super cool. I'm learning something new. And then we have immovable, use gravity, discrete, very cool, robot agent. All right, then we have our base, which is irrelevant, it doesn't do anything. Then we have our rotator here, which is the first part of our robot. So I don't know, I'm just gonna move this out for a moment and disable this, just, I don't know, to go step by step, I think makes sense. So cool. So I'm really excited about this. So the next part is going to be what? The base. Which is the base? What is the base? Mesh render. This part, so the bottom part essentially is quite similar to whatever we have, is the base. Alright, so what do we have here? We essentially have a mesh collider, that's okay. Articulation joint controller, wow. Rotation state, non-positive negative, speed 100. So this is probably the motor script. Alright, so this is a joint, so I wanna check this out and see how these guys are doing it. Oops. Oh, doesn't wanna. Okay. I hope we still see enough. Yes. Just to see where we got things wrong. Use gravity. Do we want to use the gravity all the time? I don't know. Fine, whatever. 0 continuous, I'll keep it to discrete, probably gonna change it later. Match anchors. Snap anchors. 90-degree. Revolute. I think that makes sense. Like if we check out this revolute, right? It's turning around in this direction. But is it the same for us? We're turning in this direction. But in their case, it sits flush with the edge of the base. So I'm not sure if we should be doing that as well. Did they change the position somehow? I don't think. But so this one has the articulation body already. Which is this guy down here actually. Okay. Okay. So here, so the base part, so this should be the base, I suppose. Okay, let's remove that again. Let's put it to the base and bring the rotator inside of the base, and then we can, because here we have a box collider, articulation body. Okay, but I mean here I think, okay. All right, so this is the base. We use immovable here, discrete, blah blah blah. Okay, so then the rotator. So this is their next part essentially. Let's turn this on. I don't know why it's kind of hovering up here, and they haven't changed. They haven't changed anything. So snap anchor. Oh wow. Okay, cool. All right, cool. Revolute free, and then what? Stiffness, very high. Damping somehow. Okay, let's just match that for a sec. And then I'm just thinking that, so they moved it a little bit upwards. Maybe that's because they don't want to have like any sort of friction. That's probably, let's say we remove that. Oh no. Okay, this is actually 8 centimeters, so definitely they have something in mind here, I suppose, but I'm not sure what this is. Okay, so the friction, there's definitely some sort of friction if this is moving, but I thought there might have been a distance. Okay. Anchor position, that's by default when we use the snapping. Alright, what else? Joints. A lot of different joints with the base, shoulder, elbow, wrist. Wow. Elbow. What is all this stuff? Let's just check out the robot controller for a second, what exactly they're doing here. Robot part, string, input, joints. They're literally joints. And then what do we do here? Rotate joint. joint index, rotate direction, joint robot part, update rotation state, and then update rotation state, rotation direction, rotation state, helpers. Stop all joint rotation, rotate joint, and update rotation state. So where is this function being called? Find all references, rotate controller in the robot manual input. Get rotation direction, input val, get axis. Okay, wow, this seems quite a lot. So we can, essentially what this means is that the joint that we have here, we can rotate it with a function, robot part. Okay, let's just try that. Okay, so robo rotator, yeah, let's try that. So from the robo rotator, we are grabbing turbulation body. I don't know if you have to grab that actually. So what do we grab? So this is definitely, we have to, or is the articulation body maybe the joint? Because here they, in their implementation, it's just a joint instead of an articulation body. Robot part, joints dot robot part. Is joint a custom? Ah no, it's a struct. Ah, it's a struct that has an input axis in the robot part. Okay, input axis and robot part, that's what they have in their project. Base, shoulder, robot part, and these are the different robotics parts here. Okay. Okay, so can we let's just go with one. So the joint, that's what they defined here, and inside of that we have a game object and an input string, and the robotic part joints, this is a list of joints, is this, and then update rotation, and it is this function here. And what do we do here? Articulation joint controller, robot part, get. So each of these articulation joint controller will have either a custom script okay, and a robot controller. Okay, I understand. So essentially this is what we have currently, and this is sort of what controls all of these parts. So we would have also a robot script at some point and articulation joint controller. Okay, so here what do we have? Rotation direction, articulation body, so that's what we have, right? Yeah, I think we can do similar things. Current primary rotate to. And then how do we work with the articulation? X dot drive. What is x dot drive? Is the drive, and then target primary axis joint position. Interesting. To the properties of drive along, around, or around X. Okay, cool. I think I got it. So let's say this is our robot here. We definitely need our articulation body. Maybe we're just gonna rename it to AB, articulation body. I'm not sure if we need that or if that's even possible to be used. I don't think we need this for a moment. Yeah, I'm just gonna delete all of this stuff and try it with 1. So this dot AB dot, I can add forces, but I don't want to do that necessarily. I want to say something similar here. So current articulation, and then we say X drive dot X drive. Can I say Y drive and so on? Okay, and then Y drive. I'm grabbing that, and then let's check it. What did they do? X drive. This is some sort of a variable, and then let me just grab this and bring this over. Oops, to my side, just to check. So what do we get here? Articulation drive. AD, and then what do we do with this drive? We will target it somehow. Primary axis rotation dot target equals to primary axis rotation. I don't know what this is supposed to mean, but probably some sort of an axis. Where do I have it? It's a float. Okay, the rotation. Basically the float. Guess we can just keep it to 1, and then we have to say articulation body dot Y drive equals to AD. Okay, and then we can do the same thing here and say negative. I don't know. This would be cool if this is the case. That would be quite nice. So let's see if that's already doing the trick as a very simple, let's say, example. Okay, let's see. I'm just gonna press play. Okay, are we ready? Unassigned variable robo arm. Okay. Yes, of course. Because the robo arm, okay, is turned off. Is something happening? Match anchors, discrete. Is this rotating? Doesn't look like it. Is 1 maybe too little? Because I think in this case here, rotate 2, primary axis rotation. Rotation state, rotation change, rotate 2. Do we need this? What is the speed? It's 300F actually. Positive, negative. So rotation state, but we are not really changing that. Rotation state, rotation, direction, none. rotation state, rotation goal, current primary axis. I wish, and then we say rotate to. So we have a couple of helper functions here. You know what? I'm about to just copy what they have here and see what I have to change to for this to be, let's say, working in our example. Alright, so what I learned is essentially that we have in our articulation body we have some sort of a position, so a current position, and then we well, let me think, rotate to and then we have a target, exactly. So so we have a current position and the target, and essentially we have to calculate what we or how we want to rotate with time steps and a specific speed. So that's the high level concept as I understand it. So now the challenge, the task is to actually implement that. So I think what makes sense is definitely to bring this stuff over and sort of, I'm just gonna bring this down here just so we can copy paste from it, because I mean this stuff makes a lot of sense. Definitely articulation, so the current primary axis rotation, I think that makes a lot of sense. Here we have essentially the current rotation in radians that we get from the joint position with index 0. We multiplied it with degree or rad to degree, so, and then what else do we have? Yes, that's the current rotation, and we get that in our fixed update, which is essentially the physics update. Cool. I think, yeah, I mean this makes sense, and I couldn't write this in a better way, so I think it makes a lot of sense to copy this. However, rotate right and left, I don't know what exactly we can do, or how this should look like. Probably similar to this. I'm just gonna actually, yeah, I think whatever we did here was fine. I don't know if we should just keep the X for a moment, the X drive. So this is positive, the other one is negative. That's essentially the same thing here, but yeah, so I think we can take this away. However, we have here a rotate 2. So I don't know where exactly do we have a rotation state. Aha, okay, this is the rotation state. Essentially this says rotate left or right. So how can we change this so we can keep our functionality? So I guess yeah, I don't know, rotation state could be just something like a float or rotation direction, I guess. I want to call it right, dot, and yes, so that's okay. And then I want to say something like, well, I need a speed apparently. Let's just copy what they had here. Speed equals to 300. Just gonna add this because I like it that way. Time delta, this is the current, this is our articulation body. Also gonna use this current rotation. Okay, and then this dot AB, this dot AB. Okay, so yeah, rotate to essentially, I think here we can use a negative or a positive, which is essentially that. Current primary axis rotation, and then we just add to the target, right? So this could be negative or positive, and then rotate to is adding essentially the this rotation to the target. Cool. So now the last part is that we have to, I guess we have to change these two functions of ours to change the rotation state. So the question sort of is rotation direction. So we could say something like this: if this dot rotation direction is not equal to 0, then rotate, right? And the rotation direction would be, in our case, I guess, like, let's say positive or negative, I guess. Maybe we can do it this way. Oops. But so the question is, when do we turn this back to 0, right? So rotation goal, rotate, target, primary axis rotation. So essentially what we have to check is the current rotation. If the current rotation is, so after the rotation we could actually, yeah, we could say that if the rotation goal is equal to the current, so float current rotation. So maybe we can change this a little. Okay, so if the current rotation is the same as the rotation goal, then we set rotation direction equals to 0, right? Okay, maybe this is working. Let's see. All right. Looks about right. Okay, let's try. Okay. Let's restart this. Okay, so we're rotating in one or the other direction, but we're not stopping the rotation. So that condition didn't work. So okay, but I'm happy that this sort of works so far. This is cool, but so yeah, let's peek quickly over to what they exactly did. How did they reset the rotation state? So we can actually, I guess you can say find all references. If rotation state blah blah blah, join controller direction is update. So here we essentially rotate joint, sure, stop all. So so we rotate these joints. First we stop everything, essentially changing here the rotation direction to none, and stop all joints, rotate joint. Where is the rotate joint is called? Robot manual input. Okay. But then, yeah, how is this then stopped? I think we have to create something more, a little bit more custom. So let's say we are actuating this. This is starting, rotation change, rotation direction, current rotation. So is that correct? So this is the current rotation. Aha, okay, so I think as soon as we... No, I mean this is absolutely not correct. So current rotation. So as soon as we hit rotate left, we should save the current rotation. And also is the speed. I hope the speed is not too much. So what we want to do is we only want to do this once essentially, right? But let's think. Rotation change. I mean this is... So how often is this, does this need to be triggered until it stops? So this is one increment it looks like, but then I feel like the speed is quite a lot. So let's say the increment is only going to be 1, just to see how that feels. Essentially exactly the same. Oh, wrong file. Speed. What if I even go lower? Because I have rotation of 1. What if I go lower with the speed? Because I feel like it's really, really fast. So let's try. Doesn't feel like the speed is actually changing. Current rotation. What am I missing? So, theoretically, if I hit this once, I want to add 1 degree, but that's it, right? So rad to degree, current rotation. This is what I get here, and this is the rotation change. So it should be a very small rotation change, actually. What if I immediately then say that this is 0? Let's try that. Let's see how far it actually rotates when I only hit rotate left or right once. It's probably continuing to rotate. No? Okay, fair. Okay, so okay, alright, this is cool. The only question now is, of course, how much do I rotate really, because it should be 0.1 of a degree. Yes, because current rotation is in degree, and so rotation change should be in degree. Axis rotation, drive. So I don't know if I even can kill the fixed delta. Maybe I can even, so of course the fixed delta is there to make it kind of animate, right? But I don't want really to do that. I want to go for degree per, for 1 degree at a time. So maybe actually I can just do these things here in, yeah, up here. I think that makes sense. At least I think so. Okay. Maybe I'm just gonna call this kind of void rotate. Here we're gonna give a float direction. Okay. And like this. And the direction is essentially this part. This can go away. Okay. Then I don't need that actually either. Nope, I don't need that. Yeah, I like that. That's cool. Movement helper. Missing reference, rotation. What does it say? What is the problem? What? Hold on. What? This one is the thing that is missing? I don't think so. Okay. Rotate 2. This is a helper function. This is a helper function. Here I'm rotating. Yep. So rotate right would be this, and rotate left would be this. Okay, I don't need this. Motor, do I need the motor? I don't need the arm. I need this one and the speed. Okay, cool. All right, let's try. Let's see how this feels. Okay, so this actually looks like more under control now, because let's say my speed is at 1. Can I change? Is it changing at all? Oh, hey, hold on. I'm changing something incorrectly here. So this is my rotator, and the speed is at 0, is at 1. Okay, and 300 would be too much probably, yeah. But okay, so now this should be more or less 1 degree at a time. Cool. Yeah, I like that. I think match anchors, blah blah. Okay, cool. Rotator, speed 1. probably can be much lower, but I think that's okay for now. These two things. So the final part now would be to add back our arm here. So essentially the rotator is one part, but then we also have this guy here. Let's bring that back on, and essentially I don't want to. Why are we using gravity again? Don't remember. Okay, match anchors. Okay, let's set this up. So snap anchor. Not really. Revolute, that's okay, but the Y I think is too low. So this is what I want to keep here. At least this looks correct. Free, limit stiffness, I don't know about this stuff. Stiffness, I want to keep the stiffness like that. Damping, I don't know. I think we have to experiment with these numbers. But anyway, so rotate the robot, robo arm, script. So here we can do similar, I think a similar thing. Okay, let's see. Okay, so the robo arm rotator, I'm just gonna copy this over actually, just like that. Oops, robo arm, of course, robo arm. This is correct. This is correct. Rotating left to right. So probably what I have to. Oh no, actually it should be fine. I don't know if this is correct. But let's see if it's exactly the same. Yeah, let's see if that's correct. I have a feeling it might not be the same because here I'm rotating around y-axis actually, and here I'm rotating around z. So let's see. Okay, but okay, this seems to be fine. But what I'm worried about definitely is that kind of the mesh is being distorted. Quite weird. But so what if this is sitting outside and not under this guy here? Would that make any sense? Probably not. So I think the problem is that I cannot have a distorted. No, so this is definitely not working. But so this arm is scales 111 rotator. Yeah, so I think this is a bit the problem. So why can it not be like that? So this one is, so the geometry should be skewed, I think, but not the main object here, right? So let me, how do we do this? So let me copy this, copy component, and then this is the arm, paste component values, and here I'm just gonna scale this to 111 and position, yeah, okay. What is happening? Let's bring this back out. Okay, one after the other. This is all base is, yeah, okay. I mean, these kind of things are problematic, right? Yeah, we cannot do that essentially. Yeah, okay, but it's fine. Let's fix this and then we can change how we are viewing stuff. So rotator is here, should be somewhere probably here, but the size of this I was supposed to be quite small. Oops, Jesus. what did I say here, 0.3, but it's just for the arm, right? So motor is down there now all of a sudden. I think I screwed up my prefab now, but okay. Alright, let's bring this back up. Okay, so this is supposed to be this guy here now. Actually, you know what? I'm not sure what I'm doing here, but so yeah, I'm tired, I think. So let's change it here. So here, this one should be 0.2, 0.3, 0.2, 0.2, 0.3, and here we have 1, 1, and 1, right? Okay, 1, 1, and 1. The motor is down there now. It should be 0, and then just a little bit further down, I guess, or up. So the motor is supposed to sit somewhere. Actually, it doesn't matter. You can sit in the center. Correct? Yes, I think that's correct. Okay. Then we change this to 1. Rotator. Okay. So overrides. I only want to override this and that. Apply selected. And the other ones I want to revert. So here's my my initial rotator. We have a base. Okay, the base. I guess we can bring that down somehow, minus 0.3. Okay, sure. We have the base, we have the robo agent, which is at 0, 0, 0 right now. Yeah, I mean, we have to clean all of this stuff up, I think, at some point. But so anyway, a rotator, which has a motor, an arm, which is actually scaled, which is fine. We have an articulate body here, all this stuff. And now finally we can change this guy here as well. So 5 and 3, 3, 3. That doesn't seem right, but anyway. So this is going to be 1 and 1 and 1. Okay. 1 and 1 and 1. And here is the arm. That seems to be correct. Alright. Okay. So overrides. We want to revert those. We want to keep this. How can I just apply this guy here? Apply. And this one I want to revert. Let's see. What is with this value? 0.4. Okay. Okay, and here we're gonna have 0.2. Okay, I think this looks pretty similar to the setup as we had it before. Let's see. And so let's double check 111 motor arm. That's fine. Okay, let's try that. This is the rotator. Okay, let's see. So we're rotating this, and we're rotating this. Let's just double check. The arm can increase the speed. Let's stuck. This looks great. Okay, there's some friction definitely if I touch the ground, but I think that's okay. I don't know if there's something joint friction, something I have to change still, but anyway, this feels very controlled now. I go 1 degree at a time. I think this is great. Alright, so the problem theoretically is that this guy has some sort of a friction. I don't know if I can reduce the mass to 0. I don't know if that's something. No, I cannot, of course. Yeah, this is interesting. I mean, joint friction, what does it mean? It's probably literally the joint friction, collision detection, damping force limit target, and so on. Okay. Cool. I think I'm happy about this now. Nice. Alright. So what do we have to do is we this is our agent actually, yes, taking decisions. This our base not doing anything. Our rotator, which I almost want to also add the immovable, but I think since the base does have that, it's fine for the rotator not to have it. Match anchors. Cool. Alright, maybe actually we can change this here a little. Right. So we have the rotator. That is, scale seems correct. This is fine. Then we have an arm where we also scaled, and a motor indicator, as well as an arm, like literally a mesh. The arm has the articulation body, and the rotator has the articulation body, and then we also have a base that has the articulation body with use gravity and immovable flex turned on. So in this case, I actually don't know if we need a collider, but I'm just gonna leave it the way it is right now. I think this is great. I want to override. There are no overrides actually. Do I have overrides here? For the articulation body, maybe this part probably. Apply. What? Apply. Okay. That's good. And of course I don't want to apply this arm. So alright, cool. So lastly, before I'm chopping this now, I think it would still be a good idea to continue a little bit and essentially add whatever we have here again, and to the actual arm. So how could that look like? Probably a little bit up, not too much, and I guess over. So should it be 0? Wow, okay. Of course this is kind of weird. I mean, I could now again mirror that, or actually I could just bring this over to this side, shift it in here a little. Okay, and then of course what I have to do is, this seems fine, but for this guy here I have to change again the you know, the joint. So I'm snapping this over. This doesn't seem correct. So can I just say 0.1? Yeah. Okay. Okay. And if everything goes right now, if I hit the button, this should be working. So let me actually, in my robot agent, I'm just gonna add a second arm. Of course, robo arm. Do I use any of this at all? Yes. And also the game object. Okay, get the robot arm. Okay. So this is the arm. Just gonna rename this arm 1. Rename symbol and 1. I have to clean this up, but we will do that next time. Rotator 1 and rotator 1. And then essentially I'm just gonna do copy that over 2, 2, 2, and 2, and I'm gonna have that again, but 2, 2, 2, and 2. Alright, that's that. And here I'm just gonna do this. I mean, this is not clean, but it's just for the sake of trying this out, how it would look like, and then we can think about how to iterate over all of our robotics parts. Yep, cool. Oops. And what else we got? This should be good. Okay, let's try that. Alright, so this is the first arm, this is the first rotator, second arm, second rotator. I hope this is correct. Let's try. I hope I did that correctly, because yeah. Okay, let's try. Okay, this is all. Of course, this guy is rotating now as well. Okay, but I mean it's correct. And now if I do this, sure. I mean this is interesting. Okay, cool. What I see is potentially a clash here. No, not quite yet. So I'm not sure currently if these arms have the correct speed. They don't. That's why it is so slow. Okay. Alright. So, but in theory this thing is working now. But of course we have to clean everything up. Cool. Very nice. So of course I want to individually control each of these parts and not, you know, interesting. Okay, very nice. Alright, cool. So I'll conclude this for now. I think it was super helpful to look at this example. It's good to check it out, but still I feel like it's good to also kind of come up with your own solutions and think about the way you want this to be in your use case, or in our case. I mean, of course I want it to be as simple as possible as well, right? And so the part with the update, I'm not sure, right? Like, I don't want to have an animation currently, I guess, if I'm assuming the right thing here. But this seems to, for me, this seems to be logical for that moment. And yeah, so next up would be to start controlling different parts, maybe reducing that robot actually again a little bit, and then actually designing a first task for the current robot that we have. I think that would be the next step, and a cool little let's say challenge, or a cool little intermediate goal. Cool, but until then, I hope you had fun. See you next time.